here. We'll get started. So I asked before, how many of you guys are building offline apps? And it's an interesting world of what we're coming to. So there's a lot of conversations around the cloud and a lot of connectivity. But how many of you think that with all this connectivity that we have, this has become less or more of a problem? Less of a problem? More? Yeah. Why is that? Why do you think it's getting more of a problem? So, but we get more connectivity. Right. It's almost like, the connection is going to go away, which is normal, but the amount of apps that are depending on connectivity are increasing faster than the connectivity we have available. So this is probably just going to get worse and worse. So I'm Steve Lasker. I'm a program manager on Silverlight. I've worked on many of our sync technologies and SQL Server Compact and a bunch of other stuff before joining Microsoft. So this is always a passion of mine, this space. And I was asked to give this talk, and I kind of jumped at it, even though we've got a lot of things going on with shipping Silverlight as we talked. So in this talk, since a lot of you, or some of you are doing offline, some of you are looking to do it, it's hard to do this kind of talk without a baseline set of knowledge. Because what enables offline is really a combination of plumbing and architecture and how to pull this together. Sometimes the actual work you do is all dependent on where you're applying those resources, because there's lots of different patterns to do things. So in this talk, I'm going to try to balance that architecture and plumbing conversation, so the places I do dig in to details, there'll be some context to it, and you could apply it to what you may be doing. So I've kind of put this together in this recipe, if you will, of how we're going to assemble this. And this is kind of the order I'm going to go through this to try to build up the concepts, and you could apply it to what you might be doing in your apps. Because as with many of these talks, I don't expect you to take the app as a whole, but hopefully the sum of the parts are greater than the sum of the parts. So how many of you are doing MVVM-like patterns today? Okay, a couple. How many of you are separating your code from the UI and putting it in class libraries? Yeah. MVVM is just a formalization of that pattern. So this is something that we've done over years. And if I just take a little animation here, I want to use this as the baseline, because as you go into more details of architecture, it helps to kind of know what the base is. I don't want to spend a lot of time talking about the second floor house when we don't even know whether it's floating or in the sand or on the beach or whatever. So in MVVM, we basically have these view models that collect the data from all the different sources and expose it through properties, events, and methods. Right? And then we take the view and we data bind to those view models. And that gives us the ability to create different views, whether it be for your desktop, your laptop, your phone, tablet, whatever the different UIs you want to have, with the same functionality below it. It also allows you to test. Now, it's kind of interesting when you search the internet for pictures based on text, and when I search test, it got lots of different images, and this just seemed to be one of the more relevant ones. Hopefully we avoid these crashes, or we get the error bag with exception handling if there's some kind of strange connection there. But the idea here is when you're building these apps in the view models, you're going to go out, make service calls, service returns some proxies, those are your models, and you then put those in the view model, data bind to them, and away you go. All right? Kind of a good baseline for generally how we do these kind of apps. All right. In an offline world, the concept is when you're online, you have this switch that can detect whether you're online or offline. And if you're online, you're doing the same pattern, generally speaking, right? It comes back. But if you're offline, we would have some local storage that we would route those calls to instead. So we always have some amount of data available to us offline. And then the question is, well, how do you maintain that cache? And it's not as simple as just sync. There's a lot more complexity into it, as we've kind of been through the different technologies we've done. So let's first talk about how do you determine offline state. So I've got the beginnings of an app here. and we'll put this together. Here is just very simple UI. I got a couple of properties that I'm going to data bind to for is network connected, that's whether the real network is available, whether I'm working offline, and I've got this toggle button at the top here, and a property for is online. And if we look at the XAML for it, we'll see that I've just instanced this network monitor class, and that I've got some data binding to it here below. There we go. Okay, so already set up. What's nice is one of the good things about data binding in Silverlight and WPF is if there's nothing there, it won't throw an exception. You'll get an output. So I can actually run this app already, but there's nothing interesting about it yet. So in this network monitor class, I want to expose this property for whether it is online. So I have a very simple property. In this case, it's just a getter. And then in the get, what I can do is return, let me put the return in there, system.net.network information, network interface, get network is available. Okay? So that'll return whether my network is running. So if we hit F5, we'll see that I actually have the cable connected in, and it works. If I pull the cable out, I got no changes because I didn't implement anything to do with property changes. If I run it again, I'm not online because I'm not online. So the first thing we need to do is kind of enhance this a little bit better. We need to put a constructor in here, network monitor. And in here, what I'm going to do is use the system.net network information, but there's a network change event on that. And now I can monitor the changes in the network. The only problem here is, unlike what you might be used to in desktop, is the event args don't actually give us any information on whether the network is available. And this is a basic pattern which we try to do in the core CLR and Silverlight, is to get it down to a good size, a good small size, so it's easily deployable, and to not confuse you with the 800 ways to do something. We've tried to minimize a lot of those concepts. And we already have a way to get the network is available, so you can do it there. But we need to create a method to check that. So what I'm going to do is I have this check online state method that I wrote. And what it's going to do is check that online state. But for those that are doing data binding, you know that the UI needs to be notified that a change has happened. We need to raise an event. So what I need to do is implement the iNotify property changed interface. And I'll implement an event on here, and I'll raise that up. All right, familiar pattern here? It's kind of like, you don't really pick up the phone unless it rings. Well, this is the ringtone. And the phone number you're dialing is here. So we've got this online state, check online state. So when the network change event happens, we'll just call this method. And to minimize the noise, because if the network state didn't change, I don't want to raise the event. Because by the time you get to complex apps with hundreds of properties, it can get pretty chatty. So you really want to back it, check it, and only raise a change if it actually changed, which, if I'm not careful, I'll have a little bug here, because depending on how I start up my laptop, that previous backing property may not be set right. So, network interface, got network is available. Okay. So now, when my app starts up, I'll store what the current state is, and I'll have a property that tracks that with that event monitor, and a private variable, because I don't really want my online state to be set on and off. We'll talk about that in a different way in a second. So I'll plug it back in, and there we go. And I'm now online, and I can go offline. Right? So pretty basic. Now, as with many of these things, the real-world apps can be a little more complex. How many of you have sent that mail that you wish you didn't? So it's not quite the work offline mode. It's the I'm in a bad mood mode. So we'll add a property here for bool. I'm tempted to call it the bad mood property, but I'll call it work offline. Oops. And then in the is online, if work offline, return false. Right? So now it gives me that ability to force it offline. It might be because I'm in a bad mood, or it might be you're in a place where connections are expensive. It might be a satellite connection where you're paying per byte. It might be in another country where you're paying for data transfer. So you might need to be able to do it either by the user manually doing it, or in code you detect where you are and you work offline. And what I'm going to, oops, not that one. Oops. And I'm going to put one more on here just for the sake of our demo here to show what the real network state is compared to this work offline. So here, I'm always returning whether it really is online, not tracking offline. And in my event, I'll just make sure I check that as well. Okay? So now, when I plug my cable in, I'll get, bloop, bloop. There we go. Really is online, is online. And if I take it offline, we see that we've toggled that state. So even when I pull my cable out, work offline is true, is online is false, and there we go. So now it'll stay. See, work online is true, but because I force it to work offline, I'm still in the offline mode. All right. So now you've got the ways to put in your app the I'm in the bad mood property, and you're all set. So just a quick summary on this is you use the network is available, wrap it, and use the monitor network changed event. All right, pretty basic. In your apps, you're more than likely going to want to put obviously some try-catch code around this. And while you're doing services, your network may go offline. So you want to be able to recover for that as well. And just because you are online doesn't mean you have connectivity to your resource. Right? You might be in an environment, and as soon as you plug in a hub, you get network is available. That doesn't mean that service that you might have that's only available when you're in the warehouse. When the truck pulls in, it loads up data, and it leaves, and it's not a public service. So you might want to keep track in your app of specific services that are available to you. So we got our offline state. Well, what about that local storage? So this one is kind of a big one here. So there's all different variances. How many people go camping? Okay. How many people go camping with just a sleeping bag? No tents, no nothing else, right? Nobody? I used to do that at camp, but we were young and I don't know. So the idea is you have this ability for persistence, and that basic storage I'm referring to is what I think about as isolated storage. Isolated storage is really just a storage location. It's a campsite. There's nothing there. We put some wrappers on top of that to serialize things in there. You can serialize things in there, but it's really bare bones. It's a secure location on disk. When you start doing any amount of data, something beyond the list of states and some codes, you're going to want to have some kind of indexing system. And an indexing system that can bring only the amount of data in the memory that you need. Because by the time you have a decent sized app with your product catalog, you might have 10, 20,000 items. You might have images. In the app we'll show here, we've got 8,000 different year, make, and models of cars with images for all of those. So it gets pretty big. And if you're not using something with indexing and can leave things on disk, you're quickly going to be wondering when we're going to ship that 64-bit version of Silverlight, because you're going to be making use of all that memory, which of course slows things down and so forth. And we are going to ship a 64-bit, but not for that reason. The next one is what I refer to as relationships and graphs. And the reason I'm referring to it is this, as opposed to SQL storage or something, is we've spent a lot of time getting our relational data out of the database into objects with ORMs and other technologies, object relational mappers, to bring these CLR type objects into our code, why do I want to put them back into a database and map them back again? So we want to be able to use things in our object storage, but we still want this shredding capability so that if I have a bunch of customers who have a bunch of insurance claims, and for each insurance claim I have a vehicle. So if I have 50 claims that I'm processing on my laptop, or 100 claims, but when I go and create another claim and I need to find a car, I don't want to have to duplicate those 50 or more cars. I want to index them isolated. So you want to be able to deal with the objects separately and as graphs. And those are some of there's some good stores that are coming out that are supporting that concept. How many of you are doing multi-threaded apps? If you're doing Silverlight, you don't have a choice, right? That's the design. We want to keep the UI thread free. So you always are going to have multiple threads accessing that data, and you need to have a locking system so that they don't contend with each other. And many apps we wind up seeing is they'll have so much data locally, they'll have a couple of different apps, and they want to leverage that same local store. Might be the list of contacts, might be the product catalog, could be anything. And of course, transactions. And lastly, we need a programming model that's pretty robust so that you can use T-SQL. There's stores that still use T-SQL on the client. Tend to look at LINQ as being a more object-oriented programming model that customers have gotten pretty used to. Which kind of leaves us to our conundrum here. There are lots of choices that are out there. There are more than I have listed here. And of course, we have what's coming with HTML5. And of course, that's all standardized, and everybody knows exactly what that is. Right? So this is evolving as well. And it's starting off very simplistic. If you've seen in some of the talks, you're really just storing elements in a single collection. It doesn't have the querying capabilities just yet. So with all of these, we've got a bit of an issue that we're trying to work through and make available. And each of these have different implementations that are evolving. For this particular talk, I chose to focus on Sterling because this one is a talk on of its own. There's a lot of different choices. And what I wanted to do was spend more time talking about the larger concepts and just assume that, yes, there is a local store. You can start with isolated storage. I kind of think of that as the sleeping bag version. It's very minimalistic. On a nice day, it works just fine. So we can go from there. So let's go take a look at the app so we have some context here. So we've built this reference app, which is something that we took from Mix, and we enabled it as an offline app for Tech Ed here. And as I was saying, this is one of an insurance adjuster who's going out into the field, and he's got a bunch of claims assigned to him. And they need to go to different dealerships and inventory the damages to the car, either from those people that were test driving and bumping into things, or I was in Texas for a while, and you get a lot of hail in Texas. And all of a sudden, there's these really good car sales right after any kind of hailstorm, because they're just all damaged, they're just popcorned all over the place. So in here, we've got a list of appointments. And for that appointment, you can go to a particular claim, and we can populate that information for the claim, including the year, make, and model. I can go and change to different vehicles for different that it actually turns out to be. I got our list of states here as well, of course, because what app doesn't have a list of states somewhere? And I can go and populate that with some images for the car and then mark on the different car where that damage is. And in Texas, those are pretty much the top surface areas that get damaged pretty hard. So you always want to look over the car and make sure that it's not just from the side. Anyway, so that's the main path of the app. And then I've got some other paths in here where I can take a look at the different year, make, and models of cars. If I am an administrator of the app, because the Silverlight insurance app is in different locations around the country, I might be able to configure that if I'm an administrator. And I could come over and change the color themes of my app to something pretty hideous that will be consistent through the app. And this is one of those Silverlight 5 features called binding and style setters, which is the ugly feature if you're not careful. So we will quickly revert that back. And I have some help functionality that when I'm on the field doing inspections on cars, I might want to see what, how to maintain this car, where to look under the hood, and we have some stuff in there. So the basic app, right? Nothing super elaborate. Now, back to our camping example. So of those that went camping, I didn't see anybody raise their hand. They're just using the sleeping bag. So how many go with tents? All right, a couple. Do you car camp or hike in? Right. Car camp, stay right by the car, nice and convenient. Hike in, get away from everybody else. How many of you guys go with like the monster RV and you pack up the fridge, the generator, the tent that comes out over the top? It's got the expando side, right? You got everything. Anybody kind of do that? All right. This one's not going to make sense to you then. Okay? So the idea is when you're going camping or going on the road, you're not going to take everything with you. You're going to take some time and figure out what's relevant. You've got plenty of room. You could take everything with you, and you're probably spending more time planning the trip than you're actually on the road, unless you're doing cross-country kind of things. So, it's not to say that you can't. There's certainly apps that might need that, and there's a lot of gray in there. So the idea is take a look at your app and figure out what functionality makes sense to work offline. So if we look at our app here, and I'll just bring it up real quick again, we've got a list of this functionality on the side. And, well, let's just go to Blend. And what I'm going to do is, oh, I really shrunk it down. Hold on a second. It's amazing what the mouse wheel will do. Where'd it go? OK. So in Blend, what I can do is now I can use that isEnabled property that I've got on our menu over here. And I can just data bind that to and we'll talk about this in a second, this entity manager thing. And I've got this isOnline property, which is exactly what I put in my app of what we just did before. So I'll data bind that. We'll save it. And we'll come over to here and we'll tell Visual Studio to go rerun that because it's got the updated project. And we'll get that coming up in a second. So the idea is, obviously, put code in your app for marking things offline as well, functions that shouldn't be called and the try-catch exceptions. But you want to give your users some feedback of what's available online as well. So down here, we kind of have a hybrid of the Outlook message kind of thing in the bottom, giving you the state of where things are, including whether it's online. And I've got the Go Offline, I'm in the bad mood button. And notice that those functions that aren't in the motorhome don't come with me. So I've just disabled those. And down here I've got false. And if I come over here, we'll put it online again. And if I yank the cable, it falls offline, right? So my functionality works. And I'm actually maintaining this Go Offline state. I persist that locally. So I'll plug this back in here. And we'll launch the app again. And I remembered that, I think I remembered. Did I not remember? I forgot where I left it. Anyway, let's do that again. Go offline. We'll shut it down. Come back. And we'll remember that state. There we go. So again, another place to use isolated storage or the database that sits on top of it. So I've covered a little bit of the offline, the work offline. I talked a little bit about the local store, and I just wanted to show an example of it here with Sterling DB. So what I have here is, in my project, we've got the ability to plug in different stores. You might have some in-memory store, or in this case, we have a persisted store. And one of the nice things about Sterling is that it is focused on an object model. And in this case, one of the things that we were experimenting with was storing all of those entities, and we'll talk about those in a minute, but my CLR objects, as I persist them locally, in a single container. And we assign a GUID to it. GUID, whatever. Get that squid conversation popping back in my head now, but anyway. So we have that as a collection, but I also have two others. We have another collection for messages and anchors, which we'll talk about in a few minutes. So that's how you define your schema, and then you can just query into it with link. So pretty nice implementation. Jeremy Likeness put this together. He's one of the MVPs. I highly recommend taking a look at it. And then here's how you initialize it up here. So you just initialize the engine. It's got some logging capabilities. And then, of course, I need to tell Silverlight to ask the user for how much storage I think I'm going to need. So in this case, we set it to, what, about 20 meg there. All right. So we've got our online, offline, a little bit of offline storage. We've got our car camping, maybe, our tent, not the motorhome. Now, what supplies do I bring with me? All right? He's got the whole fridge stocked up. He might even have a trailer and dry goods, and he's all set. Nuclear holocaust hits, and we're going to go try to find him. What else do you need to have with you? So if we look in even our simplistic app here, we've got a number of tables that we've got on the server, things around the vehicle, right? That image that I was clicking on that marked the damage points, those are different images, whether it's a pickup truck, a car, a motorcycle. We have information about the user. So in this case, I've got me, because I'm logged into the app, at what branch that I'm working in, right? Might be in the Pacific Northwest branch, the Central Region, whatever. And then my lookups and the meat of my app, right? I've got those 3 tables that it's the meat of the app that I want to work with. So we want to categorize this. We want to take a look at what data is just that reference data. Doesn't change all that often, Doesn't change all that often, and I just want to bring it down, store it. In fact, I don't even worry about hashing it. I want to bring all of it down. And eventually I'll get the changes. Doesn't change that often. I've got this partitioned reference data. Right? I'm not going to bring down every user in my company to my laptop or my phone. I'm not going to bring down all the branch offices. Right? I'm not going to be reassigned branch offices in the field. I could come in for that. Not a big deal. And then the activity data is the stuff that's the things that changes fairly often. And I only want my data. So I've got a partition on here that I use as appraiser ID, just a column. Could be 1 or more columns in your database, right? Same queries that you're writing. Same thing with user info. And we'll use that to filter my data that I want to bring down. Make sense? Okay. So how do I get that data locally anyway? So there's 2 general trains of thought here, kind of the right hand, left hand, and we'll talk about the dominance of right hand and righty and lefty. I guess. So one, you could just do this, what I call passive caching, which you're caching the results as they come across the wire. Every time I ask for an appointment or a list of states, I'll save it. And that's fine as long as you traveled your whole path before you actually go offline. Doesn't really work very well if you want to look at that other appointment that you didn't quite click on before you wandered out of the office because you were running late, you grab your laptop and you run off. Right? Active caching is the Outlook model. So in active caching, you go and get all of the data that you need and you bring it locally. It could be the reference data, it could be your activity data, you hash which data is actually yours. And you're going to sync those changes as they happen. The problem with this, either one, the second one in this case, is data isn't always as well structured as Outlook data. I'm focusing on always here. Right? You don't really change in mail, it's your mail. Right? Nobody's changing your mail. They're sending it to you. You might change it from different points. And when you respond to mail, you're creating another mail message. Okay? So in this hybrid approach, the idea is that the reference data, just actively cache it, bring it locally, go fetch it every once in a while. We'll talk about that in a second. But the activity data, so that I don't wind up looking at something that might be stale, or that I don't wind up killing the server to sync every couple of seconds, which is kind of the opposite effect of what you're trying to do with these caching apps, is when I'm online, get it online, save it. When I'm offline, I already have it saved. Okay? So you're kind of merging the two together. So let's take a look at how we can do that. So this is similar to MVVM that started with some concepts. I definitely want to say this is some early on thinking, and it's an idea. This is not a prescriptive pattern. Here's some library to go download. Think of this as a pattern that you can evolve on. And the first part of that is this thing we started calling an entity manager. And the first thing is people got is this tied to the entity framework? What do you mean by an entity? So this is really a lowercase entity. Okay? It's just the concept of an object. We just generally refer to these as entities. It could be a POCO manager. It could be a thing manager. But then I got thing 1 and thing 2 bounced into my head, and it just kind of makes me think different things. So we have this entity manager, which is going to sit below our view model. And then we're going to pass around messages. Now, messages also is a term that you can debate here. So call that thing 2. Because in here, we're going to talk about some behavior that's in the message. When I'm online, the view model will ask for something. It'll create a message in this case. And that message can route and request it from a service. It gets the service back. And at the same time it sends it to the UI, it'll save it locally. Right? That's that hybrid approach of the caching. If I'm offline, it'll get it locally. And we'll talk about the syncing in a second. Right? So we've been doing the passive caching approach, and we've already brought our reference data down. So now I'm going to take a little bit more of a deeper dive here into the small pool, because it's Silverlight. We don't have the big pool. We have the small pool. And I want to just kind of drill into a little bit more here. So in that messaging, what we'll do is we have this concept that we've just been using as a pipeline, that when I have a particular message that I want, in this case, the get appointments message, it's got some behavior associated with it, and it's got a method called online operation, so that when I'm connected, that's the code that'll execute, versus the other code that'll execute if I'm offline. Okay? So messages don't usually have behavior, so now you see why I'm giving all the caveat to the term message here. So let's not get hung up on names and Steve and Fred and message and entity manager. It's the idea here. And then what will happen is, regardless of where that data came from, we'll process the results, bubble it up in an event, and in this entity changed event handler we have in the view model, we'll go get that data and put it into our view model, and life will continue where it was before. Right? So the idea here is we're trying to keep using the services, keep our view models, and implement this in the middle. And we're still using the same models that you had before. Still with its validation, all of that's still the same. So let's take a look at how we can pull that together. So we've got a project here, and I'm going to go to this adjuster view dashboard. In fact, if I'll just run do I have it running? No. So this here is our dashboard, and it's our adjuster's view. We have the list of appointments, right? And those are the things that are assigned to him or at any one time. So in the view model, when it loads, we're going to tell this entity manager to process a message for get appointments. And if we look at the get appointments message, we'll see that in the constructor, we're going to configure how this guy should work. So in this case, we want to prefer the server over the cache. All right? If I'm online, go get it. If I'm offline, go get it from the cache. Right? Prefer one over the other. And then in the online operation, we're going to just use RIA services. As you'll see, it doesn't really matter what you're using. RIA services, WCF, just happens to be what we've used here. And I'm using this data service, which is the instance of my data context. And I'll say get appointments. And if we look over here, let's see, down to our services. In here, we see get appointments. We'll use RIA services, get an adjuster query, and then we'll run that adjuster appointment. Run adjuster appointment query. Where is that? There we go. And it'll go back to the server using the RIA services proxies, pull it back, and create a callback. Okay? So we'll get the appointments, and then what we're going to do is instead of sending them directly to the view model, we're going to package it up in this container for the pipeline. We'll mark it that it was a read operation from the server and the appointment itself. So we're bundling up this message and we're going to save it off. And if I'm offline, we'll go get it from the local store, the object store that we have locally, which read cache and the entity as well. And then in the view model, because the pipeline will wire that up, send up the event, in the view model, what I'll do is I have the on entity changed. And in the view model, I can get lots of different types that come up. So this is what's nice here. Instead of having to monitor strings of table names or different things like that, I can do basically, think of it as table changed events. And I'm going to say, if it's an adjuster appointment query, I care about that. If it's some other type that changed on this view model, don't care. Just toss it away. Ignore it. And then I've got, if it's a read or an update, the upsert, I will get that appointment. I'll keep track of whether I found it in the collection. And then, there's plenty of different ways to do this. This is just one of the ways we did it here for the kind of verbose ways to kind of make it for a good demo to articulate what we're doing, is we look in that list if any of the appointments we currently have matches our current appointment, and we're matching it based on the GUID. And if it is a match, swap it out. Now in this case, I'm looking at on a calendar. I'm not changing data on here. On the claim, if somebody else makes a change while I'm editing it, I obviously don't want it to swap out. I want to keep my changes and be warned that there's a conflict. I found it. I might be a selected appointment, so I track that. And then if it wasn't found, I'm just going to add it to my appointments collection on my view model. Now notice I'm just doing add here. I'm not worrying about what the order is. We'll talk about that in a minute. And then in the delete, if we find it, we'll remove it. Okay? So subscribe, events, bubbling up, and we manage our collections. So let's drill in a little more here to make the demo a little bit more interesting as we go through it. So when we're syncing that data, that was the key piece there that we kind of skipped over. What we can do is instead of initiating that message request from the view model, is we're just going to have this timer and this sync manager thing go and make the same requests. And the whole idea here is, hold on a second, get rid of that and do that again. I like my animation kind of quick. So it comes back and we're doing the same thing, right? If a change comes in, if the view model cares because we're monitoring the types, it'll see that change whether it came from the sync manager or it came from a request that it made itself. And then if you remember, we categorized all our data into two major categories, but it could be more. And I just run those on different intervals because the reference data doesn't change that often. My activity data changes pretty often, and I want to be a little more aggressive around looking for changes when I'm online. And if you're offline, just shut off the sync manager. Okay? So how do you get those deltas? Right? So there's a couple of different patterns for doing this as well. The first one is this server-side tracking. Now, this is the model that I'm going to come up, And I'm going to say, hey, server, you got my changes? Steve, yeah, oh, hold on. I got this big box for you that I've been tracking for you all along. Here you go. And it's great because I didn't have to give it much information. I just said, hey, I'm Steve. Here you go. Now, for everybody that's in the room here, imagine the server is tracking every one of those changes for every one of you. And imagine that some of you may come and never come back again. I'll miss you. I wish you would. But that's a lot of work for the server to be tracking each individual user's changes for what they care about. Now, this is a technology that makes sense in some cases. In fact, we've shipped it. This is how merge replication works in SQL Server. Right? It does server-side tracking, and it just can feed you changes really quick. The problem is it doesn't scale very well in the bigger picture. Right? Merge replication scales for what it does, and there's some really good books out there on how to do that, and I really recommend it. But when you're talking about web scale, it doesn't scale very well. Right? You basically don't want the server to have to keep on that workload. So with things like the sync framework and sync services for AD.NET and even some of the change data capture features that we've done in SQL Server, it's keeping track of what changed. And then I could come up and say, hey, what do you have that's changed since Tuesday at 2 o'clock? I don't know who you are. I don't care who you are. Well, yes, you've been authenticated, so I trust you got in the room, and I trust who you are. But changes since 2 o'clock? Here you go. So that's a much easier thing to track, much more efficient, and quite frankly, it's much more service-oriented. So now your services that you guys have for get list of states, get list of products, all you have to do is add one more parameter to it that's basically a change since, and you're just cranking. All right? Pretty simple. So we refer to this as anchor-based changes. You got an anchor point, and I want the things since that point. What you would do is you could create a sync group with one or more, and you'll specify how often you want to sync that sync group. Your reference data, if California falls in the ocean and Puerto Rico becomes a state and Seattle gets melted from whatever drifts across, I don't know, not very politically correct, but whatever. You probably can wait a day. Probably not that big a deal. Probably kind of nice to reduce that workload of asking the server for the same list of states, the same list of states, the same list of states. If that was a human, they'd slap you and say, stop asking me. I already told you. So cache that. But the activity data, all right, you could ask me a little bit more often. And then what you do is that mapping that we did earlier, you can map it into one of those sync groups, and you keep track of when I execute a sync group, these are the things that I want to synchronize. And in most cases, not all, in most cases, your sync groups don't have to be transactional. If you only got halfway through the reference data, when you sync again, just pick up where you left off. So that's why we're storing the anchors here at the entity level, lowercase e. So what make up deltas? So the inserts and updates, fairly straightforward. But if I deleted it, where did it go? How do I know to tell you what was deleted? Now, many of you how many of you are implementing like Sarbanes-Oxley kind of thing where nothing ever gets deleted? Yeah, a couple of you guys. So you're like, I'm already dealing with this. Finally, I get a chance to use that. So, but we have this concept called tombstones, and Santa's still around, so which is a little different than the concept of tombstones in phone. So this is something that's been known in the sync world for a while, and phone is kind of used in a similar concept. It's a reference point, but we keep some data around, and the way we do that is databases have triggers. They're really convenient for this case. I don't recommend trying to do this in code because if it doesn't work, something's not running, you can have a problem. But triggers are awesome for this. But similar to our headstone, we don't have a whole picture of the body up there, right? We just got his name and some dates, some interesting information. So with the tombstone tables, just store the primary key, one or more columns. If you're hashing it, by user, in this case the appraiser ID, and when it was deleted. So now I can ask for those inserts and updates, and I can track the created and last edit date on the main table. And when I ask for deletes, I'll ask for what are the deletes since my anchor point for me, for the appraiser ID. Now this works for what we call data repartitioning as well. So imagine those appointments might get reassigned to somebody else. I need that appointment pulled off my list, but it didn't really get deleted. The appraiser ID got updated. So what I can do is create a tombstone entry for me, and the other person will get it because that appraiser ID will be them, and their last edit will be greater than the last time they were there. So different ways to manage that, and you can leverage that feature. And you just do that for the tables that make sense. So I just duplicated the other activity data here. All right, let's get back to some demos here. So what I have here is in our list of messages that we walked through, because we walked through the get appointments message before, right? Well, I have some other messages here for sync messages. So I'm going to do a sync appointments message. And in this case, I've set the cache rule to be server only. I don't need a cache from the client. The whole idea is I want to execute this against the server and bring it locally. I've given it some names, which we've just implemented here, so you can put it in the bottom right corner so you get the Outlook style thing. And we'll also see some sync messages in the UI as well. And then in the online operation, again, we'll use RIA services, but this time we're going to call a get adjuster appointments delta information. And let's take a look at that. I think I still have it open here. Here we go. So on the client, that RIA services method, the proxy, if you will, what it will do is I am going to track the anchor. And so I'm going to define one, name it for the thing that I'm trying to pull out. And I've got, out of my local store, I've got that anchor table. Remember we showed that earlier? Just a collection I store locally. I'm going to get the anchor that I've named up there, and I'm going to save a new anchor. Now a key piece here is this get UTC now. Mobile users are not necessarily constrained to time zones. You want to see some ugly stuff happen, don't use UTC and watch what happens when time zone starts changing. So very, very key point there. So then we'll go use RIA services and we'll get a query. This is where I'm passing in the anchor as a parameter, and we'll get the results back. But before we look at the results, let's take a look at RIA services on the server. So here, get adjuster appointments by delta. Here's the anchor that we passed in. And now I'm just using link here over Entity Framework to get the object context, adjuster appointments, and any changes since the last time I passed it in. And then I have the same thing for deleted, the tombstones. I just query the tombstone table and pull that out. Right. So two different pieces. You could obviously wrap this up in a single service. It's just one of the places we've leveraged RIA services here. And let's see, that's in the data service, and let's come back to the view model. So now, remember this guy, let me come back to here, get adjuster appointments delta, it's, sorry, not that one. Here we go. This one, what it's going to do is get the inserts and updates and create them. Notice I set the entity sync operation to update. I'm keeping track of my updates. Don't really care about insert and update. For local stores, we tend to use this concept called upsert, which we can do in SQL on the other side also. It's just an optimization. I don't really, just somewhere down below, figure out whether it's already there, and if it is, update it. If it's not, insert it. Don't make me think about that all the way up the stack. So in this case, we just said update. And then we'll get the deleted ones with that same query from the tombstone table. We'll load that same collection, but we'll mark these as deletes. And then I'm just going to save the anchor when I'm done. So I've got my reference point when I'm done. So then this is where it all comes back. So I've got all that service stuff that I've got. I've got it from the proxy. I went to the server, got the data, brought it back. I constructed those objects. And now it comes back into this one. And you'll see that this is where I'm saving those as read from the server and the actual entity that came back. In this case, I'm not really dealing with updates. I don't care. And delete server and the actual entity. And then if we look, let's see, that's our online operation. That's the get appointment, sorry. Sync. Right, so we're done there. And then if we look at the view model, if we remember, we have that same code that'll bring it up because it'll come up in an event. If it's a read or update, it's going to update my collection. And if it's a delete, it's going to remove it from the collection. Okay, straightforward. Let's take a look at how this works in real world. So do this. So now I'm actually working offline, so let me put this back online. And I'm watching my appointments. And if we look, let's go back over to SQL here. And I'm just going to insert one. Just going to keep it simple. I've got a new appointment that's getting assigned to this person, and poof. And if we watch closely, the next time the sync kicks in, it'll show up in my collection. Come on, you can do it. Did it go up? Sync now? I know I can, I know I can. There it is, Rebel Movers. So it came in. Now, remember when I said I just added it to the collection? Well, what did it do? It added it to the collection, but it's sitting at the bottom. It's not in the right order. Now I could go back to my collection and keep track of things and insert it in the right order or requery the whole thing. I don't need to do all of that. One of the really nice features in XAML is I have the ability to use something that's called a collection view source. And I'll come over here to my view. And in my home view, right now I've set the item source up as a binding directly to the appointments. What I can do is comment out this code and set the binding source for the list item source using that collection view source. And I can specify the property name to sort in ascending order. Now, this is a little bit more verbose. You should just be able to set a collection view source a little more directly. Didn't get a chance to figure out why this is causing a problem, but collection view source is the thing that you can use here. So it's automatically sorting for me. So we'll save that, and let's run the app again. So now I don't have to worry about that ordering, right? One of the beauties of .NET and Silverlight and XAML and all these technologies is I only have to deal with a certain amount of functionality at a layer. Let something else deal with it above. Kind of the MVVM pattern. It's what we're proposing here with the sync with messaging. So now I got that Rebel Movers guy, and it's at the top of my list because he's early. That was 6 a.m. That's a little too early. So let's go over here and change that appointment time. And now what we'll see is the timing worked out a little better. And notice it moved it down to 2 o'clock. And it's not quite the last appointment. So sync kicked in, that it found that entity, right? It matched it, and it updated it to the new one. And with data binding, an event was raised, and the UI said, oh, I got to change the event, and I'm just going to listen to it. And lastly, we can delete it. So turns out that guy was kind of flaky, and he decided doesn't actually need any damages. He kind of buffed it out himself, didn't want to pay the claim. So it's gone. All right? Now, if I was offline, those changes would be queued up. When I go online, it'll just go, hey, server, what do you got since 30 minutes ago or whatever, and away you go. So let's take a little bit more look at some of that syncing there. Where was I on my slides? No, yeah, I got to do one more demo in here. So we talked about the querying, but I didn't really drill into the whole way that syncing is running. So what I've done here is we've got something we call cache monitors. And in this case, we've implemented a polling cache monitor. Right? Every once in a while, when I'm online, go ask the server for changes. Depending on your environment, you might want to set something up and do duplex connectivity. There's some overhead associated with that, but that might work for you as well. And there's lots of different ways. So this is just one model. And what I've done is we've got just a simple start, stop, and the loop itself that we run, which we're running kind of aggressively here for purposes of the demo. And while it's running, execute sync. And in the sync, we check, we have the isOnline property on that entity manager that we've created. And if it's not syncing, go through the loop. All right? So in the last activity, right, so remember we had the activity data and the reference data. Those are the 2 points. We add seconds for the interval of how long I want to wait. And let's just show that here. If I go to sync settings, we've got an activity of 5 seconds. So we're pretty aggressive there. And what is that, 5 minutes? 65? Yeah, anyway. 5 minutes for the reference sync interval. So obviously you would multiply that a bit. So we'll add that up. And if it's less than now, we'll go and sync the activity data. That's that sync group. And we'll just save the last time we synced. And we'll go through and sync the next one the same way. And if you have 12 sync groups, then you just kind of have 12 sync groups and just pop that in there. And then, and of course we have the sync now. That's the, I'm not very patient, give me my data, right? Let me know if I really pissed off my manager and got that mail back really quick. So you gotta have that functionality as well, and we're just kind of setting the time and we queue it up. And then in the sync reference data, again, same thing, we just send off a message. And if we look at here, we've got the activity data, again, it's another message. If we go back to our messages, we looked at the appointments one, but let's take a look at a state message. Now for states, we don't ever, hold on, I thought I had a different one. Maybe it was claim. Sorry, here, get states. This is what I wanted to show here. So for get states, when I get it locally, there is no, it's cache only, right? Because the states, I don't want to go and ask the server real time, even if I'm connected. Offload that work from the server. Nothing's changing that often. Get it from the cache. And then synchronize the cache. Because notice here, there's only an offline operation defined. There's no online operation. The online operation is done by using this sync here, is we just go into the server and get the state delta information, and we bring it locally. All right? So let's come back. All right, how are we doing? Pretty good. So talked quite a bit about all of these, making sense, right? Idea here is we're using messages to intercept in between the view model and our services, and we process those depending whether we're online or offline, and we queue those up with sync as well. But what about saving, right? Apps, especially business apps, tend to do a little bit more than read, right? We need to actually go out there and make changes to this data, and how do we save that? Well, it turns out it's just another message. And what I want to do is I'll probably want to save it locally first. Because the beauty of enabling occasionally connected apps or offline enabled apps is you can really start to make that network instability transparent to your user. So how often do you want to go save and the user gets annoyed going, oh, it's offline right now? What do you mean? Looks like it's online now. Do it again. So kind of, or, the web page model where the page just disappears. That's really fun. So in this case, what I'll do is I'll save locally and queue up a message. And as long as I'm online, go and send the message. But I've always got the thing locally. And you could keep track of whether you've sent it server-wide and it's server-side or it's local or not. But the whole idea is save locally and then sync it or queue it up. Let's take a look at that one. So, all right, I'm going to run this one again. So we've got our appointments, and we'll come over here, and we've got the thing. Oh, you know what? Let me show this here. So I was talking a lot of these messages. What we can see here is these are the messages currently in flight. And you can kind of see right now the main thing that's going on is the sync appointments, claim damages, and claims. And those names, what you see there, come from those strings, if you remember I had back in those classes that we defined. But there's quite a few messages that have gone on with this app as well. And you can kind of see, in fact, there's some that are redundant. It knows the message is redundant, and it just says, oh, I already have that. I'll use the one I have locally. So that's kind of nice. But I need to go make changes. Let me get back to what I was doing there. So it's not really Mary Sue Jojo. We'll get rid of Jojo there. And it turns out it's actually a blue Impreza hatchback. So now what I'm going to do is I'm going to save this claim, and if I look at the save claim message, right? So here we come in, we say saving, it's a cache rule of server only. So the whole idea is we're still going to save it locally, but I'm just the model, the way we've done it so far, we just deal with it on the server. And we save some information so that when it save actually happens, we'll pop a dialog. We save it locally, and then in our online operation, which only happens when I'm actually online, so if this message can't be processed right now because I'm offline, this message will stay in the queue that we've got locally, persisted. And it'll keep on hydrating it. One of the things about RIA services is when you have objects that are detached from it, in this case we're saving them, when you reattach, you need to tell it whether it's dirty or not. And the way you can tell it's dirty is you change a property on it. So I'm going to just change the last edit date, even though I'm going to hit F5 and I'll come back to that because otherwise it's going to time out. We want to be able to change it so now it's marked dirty after it's been put back in the data context. So now when it sends it back to the server, it'll know it's an update. So that's just the trick that we're doing there. And then we just call RIA services with a submit operation. And what you saw over here was in the save claim, if it has changes, which it knows because I changed the last edit date, it'll tell the data context, submit it, and pass it back in as the object state. And it goes to the server, saves it, comes back. And if we go back over to SQL Server and query that, we'll see that Mary Sue is no longer Mary Sue Jojo, and it's an Impreza hatchback. It's blue. Okay? So that's basically that. So, if we see it's, just a pattern here, that is the main thing I'm trying to talk about here. The actual implementation, it's a sample we put together. The idea, again, is staying with what you already have, using different stores, and keeping track of your services and just synchronize them. That wraps that one up. So in summary, as we talked, this network resiliency, it's not like you're going to go stick some piece of code in your app and cache everything, and everything's magically going to work. Right? If you look at how resources are managed, that handle on the toilet, it's attached to something. It's that tank of water, right? It's queued up. You have garbage cans in your house. That's another way of queuing. In Seattle, we have retention ponds, because when it rains a lot. We need some place for it to go. Whether it be his huge monster tractor trailer he has for camping, or your refrigerator at home, or supply systems. We have warehouses. This is how all scalable systems are managed. This concept that we're just going to have the whole world interconnected on one big wire and it's just going to work all the time is just setting your companies up for failure. The more they're dependent on it, the more likely they're going to have happen. So that's why I just talk about build this in from the beginning. Your users are going to be happy because they're not going to get those errors. Your business is going to be happy because things will happen. And when it does, they won't even know about it. Now, you can have this all enabled in your app and don't turn it on. And when the world falls down, you can go flip it on and look at how wonderful you are. But this is extra work. Don't get me wrong. We know that this is extra work to add to your apps. And we have some work to do that. But that's why I kind of say is continue to usability and stability. So we have several hands-on labs related to Silverlight and RIA services and the MVVM patterns. There are a number of sessions. The ones above the bold one, they have happened already. But you can look at recordings. And we got a couple left today. Definitely, there's stuff on silverlight.net. That's my blog. The sample that I just showed, we published that this morning. You can download it. It's on Codeplex. I would ask you to please fill out evals. They're very helpful for us. Yeah, so that's why I did that, is I actually end on that one. So with that, I thank you. I'm Steve Lasker, and I really appreciate you guys coming, and I'll take some questions. Thanks. So if you want to do questions on the mic, I try to do this ending on the right time to leave questions there. Anybody? Thoughts? I'm sorry, what was the local storage? So in this case, the question was, what did I use for the local storage? And I'm using Sterling DB, which I meant to put a link in there. So just to look on Sterling DB on Codeplex. Really good solution.
If we were going to make that data available.
Oh, sorry, the mic is on. Go ahead.
If we were going to make that data available online to clients, for example, how secure is it in isolated storage?
Yeah, so the question is, how secure is isolated storage? And it's as secure as the user.
Okay.
So think about it, and so this is some stuff that we've been through a number of different times. How secure is the Word document or the Excel spreadsheet with the whole price list and your customer list on your user's machine?
Right.
It's another document.
Okay.
Just think of it as another document. We did do work in part of isolated storage is partitioned per site. So the idea is that another site can't go down and grab it. So that's some extra security. But generally speaking, just think of it as the same security model you have as your document. If your laptop gets stolen, make sure it's locked pretty quickly. It times out. Anybody else? Yeah. So the question was, did I use the local clock for the anchor? So if you're offline, what clock are you going to use? So yes. So the assumption that I'm doing there is, well, one, I do bump it to UTC, so I make sure that I'm converting it. But I am assuming that I'm using the operating system's synchronization of time with a clock. So there's some subtleties in there, absolutely.
You can determine how many seconds you have time difference between the server and the client, and cache it somewhere, and then use that. Every time you do a thing, you make a call.
You have to make sure you lock down the users, though, because I've had users which they want to modify it, so they change their computer time back.
Yeah, so there's variances on that. So part of it is the variance on time sinks, because it could be off by a little bit. You could certainly on the server back the time back by a couple of seconds, and you just make sure your app deals with things. Like that's why I refer to the upserts. If I delete something that's already deleted, that's not an error, right? Toss it out. If I update something that was already updated, big deal, right? So there are some variances in there, absolutely.
You mentioned the network interface is available. Now, many machines do have multiple network adapters. So how does this particular machine behave in that case?
So the way Silverlight works is it's really asking for one and only one. The network interface has a collection of network cards, as you said. It's basically just doing the highest level bit. With features like we've got in Silverlight 5 that it's coming, you'll be able to use pinvoke and you can drill in deeper if that's more interesting. Generally speaking, you're trying to, this is why I was talking, because even though a network card may be available, still doesn't mean the resource you want is available.
I mean, because in many cases you have wireless plus you have but I mean, in the real world, you actually don't really care about network interface, you care about your web service.
Exactly.
So what would you advise for picking the web service?
Yeah, so it's two levels, and that's why this part is still as relevant, because if the network card has nothing, because if I plug a hub in there that's got nothing else connected, network is available. So that doesn't mean my source is available. If I have no network, I have no chance of getting to my service. So it's the next line of defense. So you first, offline, online, bad mood, good mood, network is available. And then what you do is generally, the pattern that we wound up doing was actually try to make the service call. And if it is available, execute. If you get an exception that's related, because you can track the exceptions that's related to a network failure, store that value, and then you do this fallback mode where you have another service that you start pinging. And if you don't have ping available, you can basically make a very lightweight service call, and you make that, and so it's got no database access or anything. And so then what you do is you've stored the fact that service is offline, and any other calls from your app won't make attempts. But this other background thread that's doing this lighter weight thing will keep on doing that as long as you're online. And when it comes available, then you flip the bit and you let your messages start flowing again, assuming that the network is online. So there's several doors and several monitors that you put in place.
We actually did something like that. We used web client as a pinging mechanism. We actually went the long route with, we can do like sockets in Silverlight,
Yeah.
but there's some security restrictions on what specific socket numbers, and then you need to change your client access policy.
And then depending on what you said, certain ports are closed down and ping may be closed down. That's why, generally speaking, the easiest way to do it is to just have a very lightweight service. In fact, if you look at a lot of the network monitoring systems that people put in place, you always provide them some service that they could keep on asking, are you available, are you available? So use the same thing.
In your presentation, you had SQLite somewhere down below. Now, SQLite is small, I believe 120 something kilobytes. You can't really, you need to install it on your machine. So you can't really, I'm comparing it against the Sterling engine that you integrated.
Right. Yeah, there's trade-offs with all of them. SQLite, a lot more performant. It's got a real query processor. It's got all that features. A, you got to install it. B, we actually don't. I don't believe it currently works with Silverlight. People were going to do some wrappers. It's also a relational store. So I believe in relational storage with objects in it, and I would abstract it because I want that query processor. It's just none of them have a perfect solution across the board yet.
But the Sterling engine, that should be able to just right mouse click and just say run on my machine.
It's just a set of transparent DLLs, yeah. So
Well, and you mentioned indexing. Does the Sterling have actually indexing in place? My understanding it was pretty much linking objects.
So the Sterling have indexes, and he's got a basic set of indexing systems in there because he serializes the objects and he puts them out across isolated storage, and then he keeps a separate hash for the index, so he can only load the stuff from disk that he needs. So I wouldn't say it's as robust as some more of the engines that you have to install, but like you said, it's transparent assembly, so you can deploy it with your app. it certainly gets you much further than isolated storage. It's just not as robust as other engines that we just don't have a great solution for yet.
Can I assume that the whole database gets memory with Sterling?
No, from what I've seen, and this is why I really wanted to do a whole session just on the data stores, is he looks like he's doing a pretty efficient job of only putting in memory what you actually need. That's why he uses the indexes, for instance. So the indexes might be in memory, and he figures it out, but he's only loading the entities up as you've requested them. Yeah.
When the user is offline, how would it launch the application?
How would what?
Launch the application.
Oh, I didn't go into that. Sorry. So Silverlight has an out-of-browser mode. So you basically can, dang it, I meant to do that demo. Yeah, I'm sorry. Well, if you noticed, I was actually running it from the start menu a couple of times. So I actually, so anyway, hold on. So if I right-click and I say Install Silverlight Adjuster, it will actually install into my start menu. So now I'm running out of the browser. It's just a little bit more difficult to debug out of the browser and hit F5 each time. So that's why I did that. And the way you set that up is you come over to the project. And this was added in Silverlight 4. Stop debugging here. Go to Properties. And here, out of browser settings. So see, I have Enable Running Application out of browser. And there's some settings in here. That's what gave me that context menu to say install. And then I can launch it right from the start menu. And we'll see if it didn't bury it somewhere. But oh, it's right there, actually. So that icon shows the one that's actually in my program files. Yeah?
If you have a browser, Silverlight control, is it also doing the same logic and then it goes to check for updates?
Absolutely. It's the same exact app. Exact same app. So how does it get updated? So the Silverlight has the Alexander, help me. The network, it's the check for updates APIs. So when you can call it and say if there's any updates available, and you can also do that when you're online. In fact, that might be another sync group that you manage that you're checking for updates. Well, yeah, this is the app itself. No, so the app itself, you have to do the check for updates. Yeah, this is Alex is just referring to the Silverlight runtime. Obviously, that goes with Windows Update or WSUS, whatever you guys are using in your company. But if your app, you publish an app update, and just like you're checking for reference data updates, you're going to check for application updates, and you bring them down. It doesn't run on a background thread. And once the app is running, you just don't have to check it.
So if I were to like deploy these apps on my server, I don't have to write the code to make sure it's going to get out of browser.
Well, if your apps are running, so a lot of the LOB apps, they tend to run for like a week. They don't really shut them down. In those cases, yes, you do. Because it.
They shut it down and restart, but it's
Yeah, I can't remember where we wound up. I think when it starts up, it does do a check. If you're online, so that's the problem, is the combination of things is if you're online and if you happen to start it after there was an update, then yes, you'll get a check. But generally speaking, that's demoware. You really do need something that checks for app updates during the life of the app. Because otherwise, the people are running their app and you guys publish an update, and all you're just going, I don't know what the problem is. And then you got to send this email out or announce on the PA, everybody shut down your Paradox application and start it up again. Yeah? Multiple web files?
No, zap files, multiple zap
Oh, zap files, yeah.
Using Prism, and we have multiple modules, different zap files. For the configurator, so 200 potentially.
Mm-hmm.
So we want to be able to install offline that particular module application.
Right.
Potentially with the user being able to choose specific components they want to have available offline.
Okay.
Maybe not all of them. So what would you advise to be our approach to that? Because if you just do the right mouse click on the main shell application,
Right.
you just get the main zap file,
Yeah, so generally what we've seen is just people doing their own storage of, they basically stream down the DLLs that they need, and either the app decides it or somehow the user, obviously the user's not deciding on DLLs, they're deciding on some kind of functionality, and you bring that down as well. So, because, whether it be online or offline, Office kind of did this for a while, like if you remember, I can't remember what version it is, until you use a feature, it wasn't installed, and you go click on that feature and you're home, and you don't have network, you don't have the CD, or you're not on the network, and you're screwed. So you definitely want to be more aggressive. That's the passive. The active caching is you want to go and at some point be smarter around what modules they have, and then bring those DLLs down themselves.
Bring them down to the user hard drive.
Yeah, you can serialize them down. I'm not that familiar with how that gets done. I just know you can do it.
But wouldn't you get security forms at that point? Saying like, hey, I want to save something to your hard drive.
I'd have to go back and look at it. I know it can be done. I don't know. I'm not sure if it can go into ISO Store into the same location as apps. That's something I have to look up. Yeah, I'm not sure. But I'm not sure what the prompts. Yeah. Anything else? I think that's me. See the next guy coming in. Thanks. I'll be down at the booth if anybody has any more questions, and thanks for coming.